welcome to Share Screen Africa, the leading platform in Africa for conservation conversations. We are so happy to have you now. And yeah, we're going to have a very engaging and interesting conservation agriculture series of talks. We're going to have 5 of them, and this is going to be the first one. And we hope that you learn a lot from this. However, for this first session, we're going to see together the learning outcomes. And the first one is that at the end of this talk, you're going to be able to define the conservation agriculture and its role in sustainable productive farming. And the second learning outcome is that at the end of this talk, you also be able to explain conservation agriculture's 3 main principles, which are minimum disturbance or minimal tillage, permanent soil cover, and then the last one is crop diversification or crop rotation. And the third learning outcome is that at the end of this talk, you're also going to be able to identify key conservation agriculture technologies like zero tillage. This goes in line with minimal soil disturbance, contour farming, mulching, and agroforestry and their benefits. You're also going to be able to outline conservation agriculture's environmental and economic advantages, including soil conservation, water retention, and biodiversity and cost savings. The last but not least learning outcome is that at the end of this talk, you're also going to be able to assess how conservation agriculture adapts to Rwanda's agroecological zones, tackling soil erosion, drought, and nutrient loss. So this talk is going to be centered around Rwanda's terrain. So, we face lots of soil erosion, and that's why this 5th learning outcome is in place. So now we're going to dive into the presentation, but before that, today we're going to learn from Professor Faris Ragwa. He's a Kenyan. He's an educator, he's a researcher, he's an advocate for soil and water conservation. So yeah, without further ado, Faris Ragwa, if you can take the lead.
Good afternoon, everyone. And Robert, thank you so much for that kind introduction. Robert has referred to me as Faris Ragwa. I don't yet carry the title professor at the university, but I'm a trainer, like he has rightly said. So that's important for purpose of recording. So I think I welcome you to today's presentation. And like Robert has said, I'm a trainer. I work in Karatina University in Kenya in the Department of Agricultural Sciences. Basically, I teach issues to do with soil and water. And in particular, when it comes to soil and water conservation, I feel like I am really at home with the subject. Yeah, like Robert has said, we do research in soil and water conservation. And my focus is especially soil and water conservation in the arid and semi-arid areas, because that is basically where we have a challenge of water. So let me put my presentation on the screen. Yeah, the topic I was given to talk about is Introduction to Conservation Agriculture. And I hope the participants can appreciate that colorful background for this presentation. I got this from FAO based on some work that was done in Zimbabwe. But basically, what I wanted to capture with this is that conservation agriculture has been embraced on a global scale. It is happening in other countries. And really, it can make a difference when it comes to sustainable agriculture. So I want to try and define what conservation agriculture is, in very brief ones, it is basically a system that aims at achieving productive and sustainable agriculture. And therefore, the emphasis is on productivity, and number two, on sustainability. And sustainability, we are talking about being able to produce high yields in agriculture far into the future. How far we mean from one generation to the next, because we are reliant on the same resource base that is land for agricultural production. Then what are the objectives, therefore, of conservation agriculture? Why do we need conservation agriculture? One is because we need to conserve, we need to sustain, we need to improve the resource base, which is agriculture, and we also need to use the resource base more efficiently. And once we do that, then we can achieve what we refer to as a resilient agricultural system that will be able to give us high yields, that is high productivity, that will be sustainable. And this way, as members of the global society, we'll be able to sustain our livelihoods. So the take home on this is resilience, productivity, and sustainability. Now, our resource base is the land. And on the land, we have a very important resource, which actually is the foundation for agriculture, and this is the soil. And very quickly, what do we refer to as soil? And before I even give the definition, let me say that soil is a living entity. It is alive. And therefore, in terms of very short definition, soil is a biologically active porous medium in the uppermost layer of the earth. And this is what allows us to do agriculture. In terms of composition, we have various components. We have the mineral matter, that is what we refer to as the soil particles. We have the organic matter, we have the water, we have the air, and we have the living organisms within that soil. So when we talk about conservation agriculture, these are the components that we need to make sure that they are in their optimal condition to be able to support the productive and the sustainable agriculture that we are talking about. So what are we interested in conserving? One, we want to conserve the body of soil, what I've presented there. The soil itself, we want to hold it in place. We don't want to lose it through forces like erosion. We need that soil, that body of soil. Number two, we need to conserve or even enhance the fertility in the soil. And when we talk about soil fertility, we look at it from different dimensions. We have the physical fertility of the soil that has to do with the structure, the depth, the aeration, the permeability, the infiltration rate, etc. of the soil. We need to sustain those important physical properties of the soil. And then we have the chemical aspect of soil fertility. And here we are talking about the nutrients, basically the chemistry of the soil, including the nutrients, the soil pH, the salinity levels, etc. And then, very important, we have the biological aspect of fertility, and this means sustaining the soil biodiversity. Those organisms that we said are resident in the soil and play very important roles. We need to conserve those because of their importance. Then we have the water as the component. Of course, we know that the crops get their water from the soil, and therefore we require the right amounts of water in the soil so that it can support crop growth. And this, you see, it will become very important when we talk about the arid and the semi-arid areas. Then we have the organic matter, also referred to as humus, very important because it enhances the structure of the soil and contributes to very important processes like water retention, aeration, and also to the fertility, release of the nutrients to the crops. Then we have organic matter, I've talked about that. Then we have the soil layer. We need to ensure that our soil is well aerated. And how do we ensure that? By making sure that there's a good balance between the water content in the soil, right? And also ensuring that we are able to allow free movement of air in and out of the soil. Like we know, as we know that crops get their oxygen from the soil through the roots. So we need to keep the soil environment well aerated. And then the microorganisms, we have various types of microorganisms and various species of bacteria, fungi, earthworms, termites, living plant roots. All these are important in the soil because they contribute, one, in the decomposition of the organic materials. They contribute to nitrogen fixation, for example, which contributes to soil fertility. And therefore, we need to ensure the survival of all those organisms that are present in the soil. And when we do all this, when we conserve all these components, then we end up with a healthy soil. And that healthy soil is able to support the kind of agriculture that we are interested in. So let us look at the principles of conservation agriculture. Conservation agriculture is based on 3 basic principles. One is the minimum mechanical disturbance of the soil. Don't disturb the soil. Leave the soil in its natural state as much as possible. And how do you do this? By making sure that unless it is absolutely necessary, you avoid tilling the soil. You avoid cultivating the soil. You only do this only when it is absolutely necessary. And that is why we use the term minimum. Other times we also talk about zero tillage. But you realize that in some incidences, some bit of tillage might be necessary. Then we have the second principle as having permanent organic soil cover. We should not unclothe the soil. We should leave the soil clothed, covered on the surface for various reasons that we shall see shortly. Then the third principle is diversification of a crop species, meaning that we should, of course, avoid practices like monoculture. We should have a rich variety of crops within our farms for the various benefits that we shall be looking at shortly. So those are the 3 principles of conservation agriculture. Whatever we do, whatever technology that we talk about, it should be able to fit within one of those 3 principles. So let us look at some examples of conservation agriculture technology under each of those principles. And we start with the principle of minimum soil mechanical disturbance. And I've seen sometimes people talk about no tillage, meaning that you're not cultivating the soil. Other people talk about zero tillage. And like the title says, others will talk about minimum tillage. This is a technology that should be applied in all situations that present themselves to us as far as agriculture is concerned. It is applicable in any form of terrain, whether you are talking about steep slopes, whether you are talking about gentle slopes, low-lying areas, whether you are talking about high rainfall areas, or even the low rainfall or semi-arid areas. So this is a technology that cuts across the entire spectrum of agroecosystems as defined by rainfall, soils, topography, etc. So under this technology, the soil is not routinely cultivated, because what happens, like now in Kenya, we are just getting into the rainy seasons. People are already preparing their farms for planting. But what they do is that the tendency is to go and cultivate, to go and dig. But under zero tillage or no tillage, we are saying that limit this to the minimum, if at all. So the soil is not routinely cultivated or plowed, etc. So, but now what do you do when you want to plant? You do what we call direct seeding or direct planting of the crop without necessarily cultivating the soil. What about if you have some weeds on the land? You apply other methods to get rid of the weeds. You can pull the weeds out if they are few. You can slash them, because what is important here is to suppress the weeds to give the crop that you have planted some competitive advantage. And if those two fail, then you can control the weeds using herbicides. I know I'll be asked the question about the control of the weeds using herbicides. So what are some of the benefits of zero tillage? One is maintaining the soil structure. We don't interfere with the soil structure. We leave the soil in its natural state in terms of porosity. We avoid creating hard pans. We allow good aeration. We allow good growth of the roots through the soil, etc. So we sustain the soil structure by avoiding cultivation. Then, of course, the result of this is reduced soil erosion, for example, reduced loss of water from the soil through evaporation, because like I said, we need the water in the soil because that is where it is available for the crops. Then minimizing cultivation also conserves soil organic matter, because when we reduce the amount of cultivation, we also reduce the amount of oxidation of the various carbon compounds, what we are calling the organic matter. So the more we reduce the cultivations, the more soil organic matter we can sustain within the soil. Then if we reduce the cultivation and reduce the oxidation of the carbon compounds, the soil organic matter, we also contribute to climate change protection, because when you oxidize carbon compounds, you end up having carbon dioxide, which is one of the most important greenhouse gases. And therefore, if we retain the soil, the carbon within the soil, we reduce the amount of carbon dioxide in the atmosphere, and that way we contribute to minimizing the global warming and the attendant climate change. Then by reducing the cultivation also, we are not interfering with the habitat of the various organisms that we talked about, and therefore we end up with a very rich soil biodiversity. And like you know, all those organisms are very important roles to play in the soil. Then still under minimum tillage, we have what we call contour farming. And by contour farming, we mean that whatever operations that we do on the land, we do this along the contour. We avoid the up and down kind of cultivation. If we are planting, the rows of the crops follow the contour. If we have to do any minimum cultivation, then the cultivation lines also follow the contour. And the reason we are doing this is that we want to create some kind of a barrier against any surface runoff, so that we reduce the amount of soil erosion. So this contour farming, what it will do is that it will act as a barrier against any runoff. And when this happens, then we encourage the infiltration of water into the soil. And when we do that, the end result is that we shall have reduced the erosion that would have otherwise occurred on our land. Still under principle number 1, we have soil reaping. And in that, you can see that picture there. That is a tool or an implement that is referred to as a reaper. It is used to dig narrow but deep furrows into the soil, which when it rains, those furrows, the water collects in those furrows, and then the same furrows can be used for planting. This one is very applicable and important when we are talking about arid and semi-arid areas, because we need as much water from the rain to get into the soil as possible. So we open some narrow furrows, and these furrows allow entry of the water and retention of the water for a longer period of time, and this water can sustain the crops, especially in the semi-arid areas, like I said. So this reaping will enhance infiltration, water retention. It will reduce runoff. It will reduce erosion, and that water within the soil can sustain the crops. I took this picture, not the implement, but the land where you can see some furrows somewhere in Kenya, in some semi-arid area. Now, we also have under this minimum tillage, what we call direct seeding, because we said we don't want to cultivate the land to be able to plant. So what we say here is that you do direct planting, and there are various types of implements that you can use to do direct planting. And one of these implements is what you can see there. This implement is able to dig a small hole for the seed and also drop the seed and the fertilizer at the same time, so that allows you to not disturb the soil unnecessarily. That's not my picture. I also got it from some literature, and it is shown there. So when you do reaping, of course, we are minimizing the disturbance of the soil. And when we avoid disturbing the soil, like I said, all the moisture, the water in the soil will be retained there, and that is good for the crops. We won't interfere also with the soil structure. We also won't interfere with the soil organic matter. We won't encourage oxidation of the same, and therefore we can realize all those benefits that are listed there. So like here, you can see you're doing two operations at the same time. You are planting the seed, you are applying the fertilizer, and in so doing, you are avoiding unnecessary mechanical disturbance of the soil. Then we go to principle number 2, which is maintaining a permanent organic soil cover. And emphatically here, we are talking about organic soil cover, and we have various types of organic cover. The most common that we can do is mulching, which we can achieve by retaining crop residue on the surface. But we can also do live soil cover, permanent organic soil cover, by a technology that we refer to as cover cropping. So when we come to mulching, we can deliberately bring some crop materials, residues from outside to do the mulching, but we can also retain the residues from the current crop, so that by the time we come to this next planting season, the residues are on the ground. And this one has several advantages, including reducing evaporation from the soil and therefore retaining the water. It includes also enhancing the soil organic matter content, because upon decomposition of this mulch material, this one will be converted into organic matter, and therefore we enrich the organic matter content in the soil. Then we also, using this, we improve the microclimate of the soil. And microclimate will involve especially moderating the temperatures within the soil, creating a very good environment for the crops, but also for the organisms that live within the soil. And by doing this, therefore, we enhance the biodiversity. We have large numbers, we have many species, and these can perform the functions that they do in the soil. Mulching also suppresses winds. And this is important because if the winds are suppressed, it means now we don't have to go back and start weeding, thereby disturbing the soil again. We enhance the infiltration of the water, very important, especially in the semi-arid areas again. Like I said, this is a photo that I took in the arid, the upper one, in the arid places in Kenya. The other crop down there is what we call lemongrass. And you can see after maintaining the lemongrass, the residues are left on the ground to cover the surface so that you don't expose the soil. Then we have enhanced infiltration, entry of water into the soil. We have reduced runoff. We have reduced erosion, and therefore we conserve the soil, and we can continue using the soil for productive work long into the future. Then we have the cover cropping. These are not my pictures. I got these pictures from literature, but I just wanted to demonstrate what we mean by cover cropping. For example, in the picture that is on top, you can see this is already, the brown is already some harvested crop, but you can see it was growing alongside some other vegetative material or crop in between the rows. And you cannot see any space of the soil that is left open. So that is the principle of cover cropping. Down there, it is more clearer, because you can see two crops growing side by side. And when we talk about cover cropping, then we have two or more crops. We have the principal crop. Like in this situation, I would want to imagine it is a crop with a deep green color. But in between the rows of that, you have another secondary crop that helps to cover the surface. And the benefits of this, of course, one from an economic perspective, is that if you have two crops, then you have two products, and that is good. But more importantly, the soil is covered. One, you are reducing evaporation or loss of water from the soil. Number two, you are achieving a better use of the soil water, more efficient use of the water in the soil by the two crops. Because if the area in the middle was not covered, that water would evaporate and it would be lost. Then this way, we are also improving the microclimate, like I've said, for the benefit of the crops as well as the soil microorganisms. We are also suppressing the winds. We are not leaving any space for the winds to grow. We are enhancing infiltration. We are reducing erosion, etc. Then we look at the third principle, which is the crop diversification, meaning that we have many different species of crops on the same piece of land. The photograph on the top, or the picture on the top, is mine. I took it somewhere in Kenya, but the other one down there, I got it from literature, just to show the kind of crop diversity that we are talking about. Up there, we have only maize and I think beans, but still you can see there are some openings. But the one down there, you can't see any space. You have a mixture of bananas, other crops that cover the ground, etc. Now, the benefits of when we talk about crop diversification, it can take different formats. You can have a crop rotation. This is having different families and species of crops in a sequence. Then you can have a mixed cropping or intercropping. Intercropping is that where you have more than one crop species growing simultaneously or at the same time on the same piece of land. And then cover cropping is also a way of crop diversification. And some of the benefits, again, is having a more climate resilient farming system. What does this mean? It means that because of the multiplicity of the crop species, one, you have distributed the risk. Because any of those crops, especially when you are talking about the semi-arid areas, might fail, and then you have the other crops to rely on. Then you have many products. You have bananas, you have cassava, you have maize, you have beans, and the more to the farmer, the better. Then, of course, we have reduced the water loss from the soil. We conserve more water in the soil. We conserve, we ensure efficient nutrient use, because when you have a variety of crops, these ones have different nutrient requirements, and therefore whatever nutrients are in the soil, they are used more efficiently by the different types or species of the crops. Then we have reduced pest and disease incidence, because it will not be very easy for a disease or a pest to spread in the entire farm when you have a multiplicity of the crops. You slow down the spread of the diseases and the crop pests. And at the end of the day, because remember, when we have this multiplicity of crops, at the end of the season, we leave the residues on the farm. This way, we contribute to the soil organic matter. And still under crop diversification, we have a strip cropping, like it's demonstrated there. You have the strips of crops alternating along the slope. And the benefits is, like you can see there, water retention, reduce the runoff, reduce the erosion. We have under diversification, we have agroforestry. You can combine crops with tree species. You can bring in livestock. And agroforestry can take different formats, like illustrated there. Then, in terms of summary benefits of climate conservation agriculture, we have climate resilience, we have a diversity of products, we conserve the environment, we conserve biodiversity, we increase crop production, and the line goes down up to number 10. I'll share with the moderator. No, the moderator already has this presentation, so they can share it at will. Then what is the contribution of conservation agriculture to sustainable food systems? We have climate resilience, we have multiple crops, we have crop diversity, we have multiple products, we have improved household incomes, we reduce the production cost. This is important. We control diseases, etc. So what I'm saying is that from an agriculture point of view, conservation agriculture is a winning principle. Then contribution to the environment. We have talked about soil conservation. We have talked about water conservation. We have talked about biodiversity conservation. We have talked about climate protection. And then you can bring in flood control, because once you allow water to infiltrate into the soil, that is one way of controlling flooding. And we leave little of the carbon footprint when we do this. At least we can boast of not contributing much to climate change. Let me try to look at conservation agriculture from the Rwanda perspective. I'm not a specialist in Rwanda, but I looked at some geography of Rwanda. like this map here, I can see to the west is very wet. It is hilly. And there are some challenges or potential challenges that you can associate with that. In the mid-row, we have gentler slopes, lower rainfall. To the east, we have lowlands, drier conditions, and all these might require different conservation agriculture interventions. So very quickly, the Western Islands, high rainfall, like I said. What are the potential risks? Deforestation, because people are converting land into agricultural land. Then the risk of runoff, the risk of soil erosion, the risk of nutrient loss, etc., including landslides. And some of the conservation agriculture technologies that you might consider for that is the no-tillage, the contour farming because the area is hilly, the strip cropping, crop diversification, agroforestry, cover cropping, mulching. So you can see that most of the conservation technologies are applicable when we talk about the western part of Rwanda. Then in the middle, you have moderate rainfall, and some of the risks that you might expect there, of course, again, deforestation, runoff, erosion. I saw that there's a bit of a grazing area. You can have overgrazing, and that can expose the soil. And again, you can come up with, you can intervene with the technologies that are shown on the left there. Then to the east, where you have a low rainfall, although in Kenya, some of this rainfall you are calling low, we might say it's high rainfall. We have risks like droughts. Drought is real. And this is where now we want to ensure that every drop of water ends up in the soil through, of course, zero tillage, reaping, mulching, so that we conserve all the water within the soil, because that is even more critical in the semi-arid areas. So thank you so much, ladies and gentlemen. This is a topic that we spend at least 3 hours giving a lecture. We are limited time, but that's what we have time for. Thank you so much for listening. And maybe if the moderator allows, we can engage in some short discussion. I will aspire to answer the questions. And
Yes.
Everybody in the forum is also free to contribute. Thank you so much.
Yes, thank you so much, Faris. I think this was insightful. As you were going through the presentation, I was reminded of a professor of mine at the college. I also learned conservation agriculture. He asked me, why do you think earthworms don't like conventional farming? And I was like, it was new to me, and I was like, I don't know. And he said, because earthworms don't like drama, they don't like too much disturbance. And he stayed with me for this long time. And then in the audience we have someone important. He's called Clement Ngendo. He's a head of agriculture engineering department at the Rwanda Polytechnic in Musanze, and they are our main audience today. We would love to give him 2 to 3 minutes to talk to us about what they do at the college, and if he's ready, then he can take the he can unmute himself and talk to us. Thank you.
Good afternoon, Robert.
Good afternoon. Good afternoon.
Okay, I hope I'm very audible.
Yes.
Okay, so I would first like to thank the presenter, the speaker of today, Mr. Fares, for his insightful presentation, as you have mentioned, Mr. Robert. And I've liked that at the end of his presentation, he also tried to contextualize on Rwandan context, if I can say. So I'm Clement Gendo. I'm the head of agriculture engineering department at Rwanda Polytechnic in its college called Musanze College. It is located in the northern part of Rwanda. Maybe Fares has been to Rwanda, so it is in the northern province. Maybe you have been there. close to, on the feet of the volcanoes, close to Lake Kivu. So it's one of the most productive place of Rwanda. So I don't have much to say because Share Screen Africa, I have been together with them for the past like 3 months. We have tried to identify some of the relevant topics that needed to be tabled here. So I'm happy that after a very, very long plan, I want to really say that I'm very happy that we have finally started. This is the first series of among 5 series of talks that we are going to have. And I'm really happy that in this partnership, we have been consulted. You know, sometimes you have partners, but they tell you what they want. They don't want to understand also your needs. But in this partnership, we were consulted, we had the say. And I want to tell my colleagues who are participants here that all the 5 talks that we're going to have with a range of experts from the network from Share Screen Africa, we have also had our say. So we have tried to see conservation agriculture, as Faris was saying, it's a big concept, although they summarize it in 3 principles: minimum soil disturbance, crop rotation, cover crops. But it is really a very big concept, and I think this is the way to go, considering the climate change, considering like Rwanda as a small country with various topographic and climatic conditions. I think this is the way to go. So I don't want to take much of your time because also I think people who are here, everyone maybe wants to ask. Most of the participants, I think they might want to ask questions, but I cannot finish without asking. It's a question I copied from the chat room. I don't know if Fares has seen it as well. Someone has asked, conservation agriculture is a good concept. We all know that this is the way to go, but why farmers are not adopting it fully? What do you think?
Thank you. Thank you so much, Mr. Clement. I think you've been a very good partner with us. We, as you said, we work together to formulate these 5 topics, and having your hand in it, it helped us a lot. We are so much we appreciate you so much. There's someone called Tufik Saji. He's from Morocco. I think he can unmute himself and talk to us, ask his question, and maybe a little bit of background of what he does. I saw in the chat room he does some of the interesting things. Tufik, I hope I'm pronouncing your name correctly. Well, he's not unmuting. What challenges do farmers face when implementing conservation agriculture techniques? Yes, that's the second question to Fares. Then we have Thomas Kipetu. I think he can unmute himself and ask the question.
Robert, can you repeat that question?
So Tufik from Morocco asked, what challenges do farmers face when implementing conservation agriculture techniques? So Thomas is not unmuting. I think we can go to Spencer Gonza. He has a question. He said he has a question in the chat. So Spencer, if you are around, you can unmute and ask your question. He also seems to not be around. I think you can be answering those 2 questions, and then Thomas and Spencer might join in later.
Okay, hello everyone. I hope you can hear me.
Yes, we can hear you.
Okay, thank you so much. What I have, it's more like a question and more of a suggestion that all of us have to put an effort to. Because me, I'm actually into wildlife ecology and conservation mostly. So I do appreciate conservation agriculture. So I saw Mr. Ragwa highlighted a lot of important aspects there. So I've seen that in most places. I'm actually from Zimbabwe. In conservation core areas, most people are practicing agriculture. So I've seen that the adoption of conservation agriculture has been a challenge, since most people who know about conservation agriculture expertise, such as you, Mr. Ragwa, and other people, ecologists. So it's been actually a challenge for local farmers to adopt this conservation agriculture, since most of them, they are living in ecological regions where there is less rainfall. So in terms of less rainfall, sometimes the soil structure changes within time. What I can actually say, it's actually wrong when I say changes within time. The soil structure is different within these areas. So adopting conservation agriculture, it's actually difficult for those people. Some of them, they implement these techniques which don't actually apply in those areas because they receive the less rainfall. While most experts know that in those areas, those people, they are supposed to be doing livestock clearing, they are supposed to be doing this, but they are actually practicing conservation agriculture, which doesn't apply in those areas. So I feel like you should play a pivotal role in actually capacitating these people so it doesn't become a challenge or even negativity for those people to have high yields, and also at the same time continue doing conservation in those areas in terms of wildlife. Thank you.
Yeah. I think, Paris, if you can unmute yourself. Yeah.
Yeah, thank you. I think that was not really a question, but an observation. If I can talk about the Kenyan experience, is that people in the high rainfall areas where rainfall is reliable, and of course they grow high value crops like tea and coffee, they can afford the conventional inputs. Really, they might see that or view that conservation agriculture is not of much use to them. They can continue with their conventional farming practices. But in the dry areas, in the arid and semi-arid areas, let's talk about the semi-arid areas, where water is critical, where you can have frequent droughts and rainfall that is even below average. I think this is where the impact is more felt. So in the drier areas, according to my observation, people tend to adopt this because they can easily see the benefits. But people who are used to, like, if we talk about Western Rwanda now, the problem there might be erosion. They can maybe put terraces to control soil erosion. So the issue of water conservation might not be a very big issue to them. But in the dry areas, I think this one would have more impact. And therefore, these are some of the areas that where we can put more emphasis. But now a technology like mulching in the dry areas, sometimes also like the last speaker said, can become a challenge because the same crop residues are targeted as feed for the livestock. So when you tell the farmers to leave the residues of the farm, sometimes actually after harvesting the livestock, go and graze and feed on the crop residues, because in certain parts of the year, this might be the only fodder or forage available to the livestock. So there's also the issue of balancing what else are farmers doing. Will you tell a farmer to leave the maize and sorghum stovers on the field, or do they feed this to the livestock? So there's also some bit of balancing required. Then again, in the dry areas, we have challenges like the beautiful animals we see in the soil, including termites. If you leave the crop residues on the land in those areas, of course, you have given the termites the food. In the short term, the soil will not be covered, but of course, in the final analysis, we end up ejecting the organic matter into the soil. So in the final analysis, it's beneficial. But having physically the residues on the surface might be a challenge in those areas. Because one, they need to feed the livestock. Number two, competing for the same mulches with the soil organisms like termites and the like. But we should not give up. I think the preaching of the gospel should continue. Thank you so much.
Thank you. Now we can hear from Thomas.
Okay, now according to the context of the conservation agriculture technologies, there's this issue of zero tilling that I don't know how can that be done in a way that some other people have been practicing the other way, whereby they dig a lot and then using a lot of machineries in the process. So which are the good ways to go and explain to these people on how can they change and adapt to these conservation agriculture technologies?
Forrest, did you get the question?
So you think that some people, of course, they do land preparation using machinery, mechanized cultivation. It is still possible to do zero tillage and direct planting, even when you're using a mechanized farming, because the disturbance of the land that might be necessary is the very initial one. Then after that, even if you're doing a large piece of land, you are growing maize, you are growing wheat or any other crop, if you start leaving that mulch on the ground using the same machinery, it is possible to do direct seeding or direct planting through the mulch. In fact, we have mechanical planters, tractor mounted, that do the same thing that I was showing using the hand planter. We have mechanized planting equipment that can do the same on a large scale. So basically, the issue of the scale of production should not be a limiting factor. I think, like I said, whether you're talking about mechanized agriculture or small agriculture, is the issue of inertia. People needed to internalize the benefits very quickly. But in both, whether people are doing mechanized agriculture or the small scale subsistence farming, I think most technologies are still applicable. Take it like the cover cropping, for example. It is possible under mechanized agriculture and also under subsistence. Because if you're doing maize, we know maize leaves very big spaces in between the rows. Then there's no harm in coming with a secondary crop, the cover crop, which even like a legume, for example, which would have the added benefit of nitrogen fixation and also reducing the amount of inorganic fertilizers that you require. You suppress the winds, you manage the pests and the diseases. So I think in whatever scale of production, I think the technologies are beneficial. Thank you.
Okay, thank you very much for that, Faris. I think Robert has just dropped out, our host. Hopefully he'll be joining just now. Are there any final questions? Oh, here we go. Okay, one last question here in the chat from Zachary. Why do many schools of agriculture still focus on teaching standard tillage practices rather than conservation agriculture techniques? And what do you think should be done to update the curriculum or create common understanding across education institutions to fully adopt and promote conservation agriculture?
Very quickly is that we should also revolutionize our agriculture curricula so that we integrate conservation and agriculture as part and parcel of the curriculum. Like personally, when I was asked to teach soil and water conservation, in the course description, there was no direct mention of conservation agriculture, but I thought it is relevant. And with the time, we incorporated that as our topic. Let's say you have 13 topics in a semester, then you can commit 2 or so topics on conservation agriculture, because it's a topic that requires quite a bit of time. So the conservation agriculture should be integrated in the course descriptions as much as possible. And I like the approach of Share Screen Africa, where they're saying that we should also be giving a talk to people or audience who are not necessarily students of agriculture, so that not necessarily for academic purposes, but they can carry that message home where they come from, and they can also try it out not necessarily for academic purposes, because if they try and it works, then they become ambassadors for the conservation agriculture approach to farming. So I think there's room for incorporating conservation agriculture into our agriculture curricula. In fact, these days, as what we are saying in Kenya is that everything that you teach, the last topic should be on contemporary issues, pertinent issues that are affecting the society, the communities. And when you talk about agriculture, one of the pertinent issues, therefore, is the conservation of the resource base, which is the soil and the land. And one way of doing this is incorporating, therefore, conservation agriculture into the curriculum, because this one will now also impact the other pertinent issue, which is climate change. And therefore, you can see that you'll be killing so many birds with the same stone. So I think for us, as we do the curricula, some of the pertinent issues that we talk about is environmental conservation, and conservation agriculture comes right into that. Thank you so much.
Thank you so much, Faris. Sorry for the interruption. You know, the internet, we don't deal with it. This was very insightful. We learned a lot from you, and I think the audience as well can testify to that. And yeah, we appreciate your presence, we appreciate your time, and we hope to see you again. We hope that this is not the last time on this platform. You're always welcome at Share Screen Africa, and that goes to the audience as well. You're always welcome to Share Screen Africa. We are about to end this session, but this, as we said, is the first of the 5 sessions that are going to comprise this conservation agriculture series. And on 26th of March, it's 2 weeks from now, we're going to have the second session, which is going to be about the economics of conservation agriculture. I know we always ask ourselves how we can make money through farming. If you ask yourself that question, then you don't have to miss on the talk that is going to be held on 26th of March. So once again, thank you very much, Faris Ragwa.
Yes.
Yeah, thank you very much. Thank you, Faris. Thank you, everyone. This was interesting, and may you have a good evening. Thank you.